In this tutorial, we're going to go over how to build a rig for a tentacle. I have a friend that requested this, so I am going to do my best to go over this. I will start with saying that I have not, usually when I do these tutorials, I'll do a dry run just to make sure I remember how to do it. I haven't done it here yet, but we'll give this a shot and see how this goes. So I've already created a polygon shape for my tentacle, just basic cylinder, and I sculpted it just a little bit so we could tell what's top and bottom when it comes to twisting and things like that. And this is a pretty simple shape. Um, I basically made a cone that was 24 units long, so it spanned across the whole grid, and then divided it 24 times, subdivided it, sculpted a little bit, deleted history. But you can see that the edges fall on the grid. Um, this is more for ease of rigging for me to demo this because I will just put a joint on each one of those subdivisions, um, which ideally is what you should do. But on top of that, this thing should be roughly evenly spaced. Um, so there's a few things to consider between your model and your actual rig that should we talk about before we start. The one I'm going to build will stretch, so as it gets longer, these segments will get farther apart. That's something you need to consider when building your initial mesh, and because you need enough segments to get a nice curvature out of this, especially if you're doing it for games. Um, so keep that in mind. How much is this going to stretch? How close together do I need to make those edges? Um, as far as how it looks, if I was modeling this, I'd try to keep these roughly square faces to start with. Um, you can't quite do that and keep them all uniformly spaced. Um, we want them uniformly spaced because that's kind of how it's going to deal with scaling later on as we stretch this thing out. Now, if you are doing this for film or for render, that's not such a big concern. I could hit 3 on my keyboard and go to smooth mode, and let's just go ahead and yank out some verts here, and you can kind of see what's going to happen. It's doing interpretive smoothing here, so not quite as big of an issue. Um, but if you're doing games, things you have to keep in mind are things like, do you have scale available to you? Do you have non-uniform scale available to you? Most, or not most, but a lot of games only give you, if they do give you scale at all, will only give you a single channel scale. So if you're to export animation, it'd be one channel, not X, Y, and Z. It's one channel for all three. Um, if you're lucky, you'll have non-uniform scale, and you could scale only in one direction, which is what we'll do for this tutorial. Um, but the solution we'll make here is not an end-all be-all solution for all tentacles. It is one solution um, that you can combine with other solutions potentially, or modify for your particular needs. But just to be upfront, we're going to do non-uniform scaling for this, but also kind of treat it like a game model at the same time. So first thing I'm going to do is I'm just going to build my chain of joints. Actually, in this case, I'm just going to hide my mesh to get it out of my way, because I know I can just line up to this grid and have what I need. So I'm going to go ahead, skeleton, joint tool, and I'm going to hold down X, which will turn on snap to grid here. You can see I'm pressing the key, letting go, pressing, letting go. It toggles on and off. And I'm going to go ahead and just click out a joint for every grid space here. I'm just point snapping as I go. And I'm going to go all the way to the end here of this rig, and I'm going to go one extra just in case. I like to go one extra joint just for whichever direction I'm going. I think in this case the default is if you go from left to right, you're automatically aligned with the world, but otherwise your joints are auto-orienting as you click out. So that one extra one, just make sure this joint is facing the right way, because it'll aim its child to face, or it'll aim to face its child as I click at the next joint. So there's our joints. I'm going to go ahead and open up my outliner here. It's down here. And I'm going to shift click this little plus box so I can see all my joints. And select them all. And I'm going to turn the radius, let's say, down to 0.2. And I'm going to go down to 0.1. It's going to be a little bit more manageable just to see this. And this isn't anything that's going to matter in game or anything like that. It's not going to affect skin weighting. It's just the visual interpretation of that little sphere. I'm going to take that out of the way. Okay, so we have our joints that we're going to skin our tentacle to. And what we're going to use is an IK Spline. Now, we could just use FK controls if we wanted. We can make a control for each one of these and manually rotate them. That is an option. If it was me doing an all-out animation rig for an animator or a group of animators, that would be one element of my rig. Basically, I would build 3 rigs. I'd have one for skinning that mesh to. I'd build another one right on top of it that would be FK only, and then have those FK controls, and then I'd do another one that's the spline controls, and I would make the skin weighted one be able to either follow the FK or the IK controls, and I'd make a little blender node that would just say, hey, you're following the IK controls or you're following the FK controls, and that way the animators could pick which one they wanted and have the best of both worlds. But it's only one or the other. You're only working with FK, you're only working with IK, and you're swapping back and forth between the two. That is an option. We've talked about doing that in some of our FK-IK matching tutorials in the past on my channel. If you're wondering more about that. But we're not going to do that here. We're just going to focus on building these spline controls for right now. So what I'm going to do, I'm trying to think how I want to do this, because well, let's start creating and going through this process, because partly the reason I am not doing a dry run is I want to kind of show you my thought process as I go through this stuff, because it's, like I said, there's not a solution that fits everything. It's project specific. So I'm going to head and double click on my create curve tool here, and you can see right now we're on linear. So if I was to click this out, I'm just going to make a zigzaggy line right now. You can see every click I get is just a straight line to the next point. Straight line to vertex to vertex, or to CV in this case. That could work for the solution, but basically what's going to happen is our joints are going to ride this spline, and they will stay spaced the same, but they will be trying to stick to this line. So, excuse me. So they may be riding one here and one here, so it never actually hits that point. Something to be aware of. And if they slide, if we start scaling these for some reason or pulling them out and they're scaling up, because we're pulling this one out, it's scaling on the overall length of this curve. A joint may be sliding and then hit that point and then slide back down, and it'll look a little bit janky. It's going to be a little bit too hard edge for us. So what we want to use is probably something more like 3 cubic here as far as our curve degrees. So again, I'm going to click out a bunch of points. And you see it doesn't do anything until I click out my third point or so. Let's go back, and I'm hitting the delete key on my keyboard, not the backspace key, but the delete key. And you can see like there's no edge there. Here's 2 points, 3 points. It's not to the 4th one that it's able to make a curve. And so what's going on is the way Maya is deciding how to make this curve, it is taking an average of these. So basically from this point to this point to this point, it's dividing, it's making an average of that and saying, okay, there's a point here and a point here. Okay, let's draw a line. Actually, let's go ahead and actually draw this out. First off, I'm going to go to display. I've selected this curve. I'm going to display, NURBS, CVs. That'll turn those CVs on so I could see them even when I'm not in component mode. And switch back to linear. So basically, the math that's kind of going on here is it's saying, okay, if that's where that point is, let's go ahead and start by drawing a line like that, where everything is point to point. And now I'm going to subdivide each one of those like this, and basically draw a line like that. And it's still hitting all the points, but and then it'll keep kind of doing an average between that, and you can kind of see how that starts to line up as it starts to average those subdivides in between. So like I think if I recall how this math works, we'd be subdividing there, 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 and it starts to make an average that gets a lot closer to that line. So that's why you need 3 points. So we're going to use that type of curve to do it. Now the question is, how many points do we click out? Because this curve, whoops, wrong type, 3 cubic. This curve will be the guide for these joints to write on. But to move them around, I will actually have to go in and deform this curve, which means I have to deform all these points. So the more points I make, it means the more points I have to translate around to get the shape that I want. So this question becomes is how many controls do I want for this? You know, what becomes easier than just doing FK? Because if you have a control for every joint, that gets to be a bit much to handle. So what we could try here, let's do one every 4. Yeah, I think that should work. I'm just doing quick math in my head, which is probably wrong, of just doing 24 units across because that's my grid. And trying to make sure 4 will go into that. For some reason, I can't do that math in my head right now because I am talking and doing a live demo. You know, also I could also just potentially click out the amount of points I want and say rebuild curve later. Where's that? It's under surfaces. Yeah, rebuild curve, and I could tell it how many knots to put in there, or the number of spans. That's also an option if you aren't dealing with even numbers like I am, and you can just click out a straight line and say, you can even click out a linear line and say, hey, rebuild this cubic. I believe it's been a while since I've done this. Rebuild curve. Yeah. So you could build out a single. You know, like let's actually do this. This might be easier to show because this will meet more cases. So originally, what I was planning just now was clicking out just every 4 spots. Doing 4, 1, 2, 3, 4, and then 1, 2. Yeah, okay, 4 and 4. And that would be less controls that we could then manipulate to start to do our tentacle. But what if, let's actually just pull this off to the side so we can compare and sanity check myself because I never know if I'm right. I always have to check. Let's go ahead and build a linear curve. So say you're not so lucky to have things lined up to the grid here. And maybe this is even a way to figure out how to place your joints because you could use the CVs, you know, turn back on display NURB CVs so you could see those and point snap to them to figure out how to evenly space your geo if the geo, or evenly space your joints if the geo on your mesh isn't uniform. So I'm going to click a single point there and a single point there. Again, I'm on linear, so I could pull that off. And I've got my outliner at the bottom screen. I'm just going to go select that second curve through there. And again, if you look at it, it's just got 2 CVs right now. I'm going to go to Edit Curves, Rebuild Curves, and let's see. I'm going to keep the ends. I want to switch over to cubic, and what do we do? 1, 2, let's see. I think it was 2 in between, so 2, 4, 5, 6, 7. I think I want 7. It's the guess and check method. I'm going to hit apply, and I believe that did it. We just couldn't see it, and so technically it did it there. except they're not evenly spaced because of how um, this is an issue with cubic curves, because I think it's looking at this as just trying to hold the shape, because if it was curved, it would need that because there's no other curve there to average between. But it looks like all the other ones did. So I'm gonna go change that to 8, 9, because you see it did it on both ends. I'm gonna undo and looking for when that says undid, and I think that's back. Yep. Let's change this up to 9. Because those N2 are, we could make that essentially 1 in the end and have it deform the way that we want. Let's go ahead and click apply. That's still not quite as evenly spaced as I was hoping. That looks like it's also doing closer to 3. So I'm gonna step back and try 8, see if that's the magic bullet. There we go. Now, in my case, how did I know that was right? I'm looking at that's right on the center divided, and then while these are every 3, that's still better. So, okay, so if we wanted to go and have it be every 4, let's try to go the other way and have it be 6. And again, this is how I do stuff. A lot of the time, editing and practice makes this look like it's perfect, but this is all the stuff I do before that I don't always show you guys. Yeah, so 6, that's better. Right in the center, and then every 4, except for the endpoints, which we kind of need if we want to hold that shape towards the end, because again, you need that third point to average to, and you don't have it, so it's kind of giving you that one. So let's run with this spline. It'll probably give us better control over the ends, so we don't get a weird taper off anyway. And when we skin weight this stuff, we'll consider this the pivot, but this one will also be skin weighted as if it was part of this one. So I'm going to close this, and I'm going to delete my curve, or the first curve I made, not the one I just made. And let me point out, I'm not going to do it here because it's going to be the only thing we have in the scene, and everything's still pretty organized so far. This is where I'd start naming all my stuff so that I know what's what. If I have multiple tentacles, I want to know which one's which. I'd put those names in. If these are skinning joints, I'd want to name those. In this case, it's going to be IK, so I'd probably name them something like, joint underscore, IK underscore rig. So I could tell them apart later. But for the sake of time, I'm not going to do that, which is bad and lazy. It's do as I say, not as I do in this case. But it's not very fun watching me name stuff for 5 minutes either. So the main thing to realize is that right now we have our chain of joints and we have the curve that we've made. So with this curve, we're going to, I'm going to go ahead and close my tool settings, make an IK spline. So I'm going to switch back over to animation. And that's my dog barking downstairs. You could hear that. I don't know if it's picking up on the mic. Skeleton, IK Spline handle tool. And I'm going to open the options. And let's see, I'm going to go ahead and reset this tool, so I'm going to have the same thing that you probably have. Let's see, I don't want it to auto-create the curve, which is going to uncheck auto-simplify. We want to use the curve that we just had there. We don't need an auto-parent curve. I don't think we need any of this stuff on root on curve. Auto-parent curve and root on curve is just how it's going to parent the stuff. I think I want this all off, if I can remember. We'll test it out and see if that's right. So what I'm going to do is click the beginning of my chain. So I've got all my settings checked on. I'm still on the IK Spline tool, and I'm clicking the beginning of my chain, clicking the end of my chain, and then I finally need to click on my spline, which you can't see because it's right on the grid there, but I know it's there, so I'm going to zoom way in so I can get in between the joint spacing there and click on that spline. And there we go. It is connected. And I can tell because I've got the curve, oh, I got the IK handle selected in this case, but if I have the curve selected, if I go and move any of these vertices now, my joint chain sticks to it. Oh, and that's where I was wrong. I was thinking of IK spline stuff. So I'm going to go back and undo. So notice as I'm moving them, this stays down. I don't want that for my tentacle. That's what root and curve does. And zoom back out. And I'm just going to undo till that IK handle goes away. There it goes. Tool's still active, so I'm going to click on that. Trim back on root on curve. And do the same thing. Click the beginning, click the end, and click our spline. Now the reason I did that the first time is because I use this also to make IK backs if I'm rigging the back of a character. And there's times where I don't want that to move. I want the hip control to drive the end of that chain. So there's been times I've turned that off. But in this case, that is not what we want. We want this effect where if I move these endpoints, the whole thing moves. And so I'm going to make this curve longer than my joint chain, and you can see right now that it slides along that joint chain. So it becomes a pathway to slide along, which can be useful at times. But for what we're doing, we want something a little bit more organic looking, and we want our rig to be able to stretch. Now, the way we'll pull that off is we will tell our joints, hey, look at the overall length of the curve. It has a current length right now. We'll store that number and say, figure out the length of the curve versus where it started versus where it is now. That's a scale value. So if it's 10 right now, and we stretch it out, then it becomes 20. That's 20 divided by 10, which would be 2. And now we know we have a scale of 2 that we can apply to the joints to stretch them out to match the scale, the overall scale of the spline. And again, you hear me thinking out loud and getting stuff backwards and correcting myself. That never goes away. So if you were doing that, don't feel bad. That's how learning goes, and it's a ton of stuff to remember, and I forget all the time, and at least know enough to be able to guess and check. Okay, so how do we figure out the length of this curve? Now, some of you may know about, where is it? Create measurements, measure tools. There we go. There's the distance tool, and we could click this guy out, and that'll tell us the distance between 2 points, which is great, but it gets a little bit hard when it comes to curvy stuff. Also, that's like 3 extra nodes, and it's extra visual, and we don't need to actually see all this stuff. We just need the value. So when you make a curve, it has construction history, and we don't really have any here right now telling us anything about how the curve was made, but we could turn it back on retroactively. So I've made this curve, and I'm going to use a little bit of mel script right now. And the mel script to turn on the construction history for this curve is arc len. So I think that stands for arc length. So ARCLEN, all lowercase. I'm going to hit space, and I'm going to do -CH. That is the flag for channel. Or sorry, not channel. That is the flag for construction history, the CH. And hit a space and 1. Because construction history is a Boolean option. It's either it's binary, it's on or off. 0 is off, which it currently is. 1 is on. So we're saying, hey, turn on the construction history for the arc length by setting it to 1. So with our curve selected, I'm going to type that into my script editor. You could also do it in this script editor. It doesn't matter which, just make sure you're in a Python tab. Or sorry, that you're not in a Python tab, that you're in a mel script tab. And again, arclen, all one word, -CH, 1, and a space between each one of those. With my curve selected, hit enter, and now we get the curve info construction history. Nothing there when we select it here in the channel box, but if we go into the attribute editor, we see a tab for it now, And there is our current length of our spline. And to show you that that is live and active, I'm going to go ahead and pull this out. And when I click on the curve again, you can see that number has changed. Go ahead and see if I can just undo that and have that go back. Not quite that much, but it's back down to 24 from 30. Okay, so we know exactly how long it is right now. We need to convert that into a scale that's going to, a scale number that's going to scale our joints with that. So let's see what's the easiest way. I will open up the node editor, and there's my curve shape. And I'm going to go ahead and create, by the way, so I'm in the node editor, window, node editor. You can also do this in the hypergraph. I'm right clicking in here and saying create node, which brings open this node creator. This is the same one you see in the hypershade. And I'm going down to utilities here to sort out, so I've only got utilities in here. And I'm looking for the multiply divide utility. And there it is, multiply divide. I'm going to go click that, which creates a new one. And again, I named this, but I think this is the only one I'm making. So if that bites me in the butt later, I'll go name it. But again, if you're doing a real rig, name these all as you're making them so you could tell what's what as you keep going, because it'll get real confusing later. I'm going to go ahead and close that. And let's see, can I just click on this? No. Okay, I think what I'm going to have to do, let me double check this. So I'm going to go to Window, General Editors, Connection Editor. And because I already have curve 2 selected, it's already loaded in the from slot. And I don't think I have curve info in here, do I? Or is it just going to be here at the bottom? No, I don't see the node that I need. So what I'm going to do is with curve 2 selected, I believe this is another separate node. Like if I went and unhit DAG objects, yeah, there's that node. So this is one way to get to that. So again, in my outliner, DAG objects only, I'm going to uncheck that. And now there's a bunch of other stuff in here. And there's curve info 1. And again, I'd probably name this thing again so I could find it, because if I had like 5 tentacles, I need to know which one's which. There'll be a different one for each spline. So that's one way to find it. It's easy in this case, as I have virtually nothing in my scene. But what if this was cluttered with a bunch of rig stuff already? Well, I could select curve 2, come over here to this tab in the attribute editor, and click the select button down here, and that'll select it also. So let's just prove that by, again, turning off DAG objects. There it is selected. But more so, I could just come into the connection editor and load that up. And here I get the arc length right there. So that's a single value, and I'm going to load up my multiply divide node. By default, this is set to multiply. I'm just going to leave it on multiply. And let's see, which number do I want to put that in? So this is the original length. I'm going to put that into input 1, and I'm going to say, I think I want input X. Now this doesn't particularly matter which one of these I pick. I just need to pick one of the 3. But because if I select my joints, X is facing down this way on the chain, that's the one I want to do just so I don't confuse myself later of what this is going to. Oh, wait, nope. You know what? I want... Okay, I've lied twice. Arc length, I want under input 2 rather than input 1. I'm going to type in input 1. Let's go ahead and bring back open my... Nope, not that window. Connection editor. No, not connection editor. Node editor. So I can select these 2 nodes easy. I guess I can in here too. I'm just used to working in here. I lied. We're not going to leave this on multiply. We're going to leave it on divide. Again, I've been building another rig and pretty much everything has been a multiply, but in this case we do want divide because we have to figure out the original length. And we know the current length is 24. So we're going to type that in because that length shouldn't change from here. There shouldn't be anything where our original length changes. The one exception may be if you're building a rig that has an overall scale, like if you grab the move all for it, that moves everything on that rig, and you could scale that up and scale that whole rig uniformly. You will have to do math that accounts for that ends up being input 1, which is basically, hey, here's the current scale, and divide it by whatever the whole rig has been scaled by, and then pump it into here to compensate for that. But in this case, we're not going to have that. It's just going to be straightforward, just this one tentacle. So right now that should equal 1. So if I plug that into my joints, they should stay the same size. So I'm going to go ahead and do that. And then we'll test that this is actually working once I do this. So I'm loading up my multiply divide node as my from, and then I'm going to go into here into my outline. I'm shift clicking to expose each one of these joints. And there might be an easier way to do this with scripting it and then just doing one connection, copying it over to insert to replace to update the names, but I'm just going to go ahead and do this manually. So output for X, so 24 divided by 24 is what I'm getting as my output right now, and X is the only thing I hooked up. And joint 1, and I'm going to scroll down until I find scale. There it is. And scale X. And I'm just going to try to, right now, visually get these at the same level. Doesn't matter here, but as I keep loading up new joints, that'll make that easier to know where I'm about to click and just kind of go through this circuit over and over. And I'm just going to hook up each one of these again and again. And if I was a smarter person, I would have something insightful to say here, but I don't think that I do. The only thing I can think of is, again, keep in mind if you have uniform scale, if you're doing a game or not. If you don't have any scale at all, you can fake this sum with translate. And right now, these joints are all uniformly scaled. Well, not uniformly scaled. They're uniformly spaced. And let's go ahead and look at it from their parent. So right now, they're 1 unit away from their parent over to the right each time. In our case, that's really lucky because that's equivalent to our scale, but probably wouldn't be in most cases. So you could figure out the math there of, okay, if we're scaling up, I can multiply my current translate distance times the scale, and I could stretch it out that way. Now that's going to be a little bit different for your skin weighting, so you're going to be limited on how much you can translate them out and not just have that look like it's a weird stretch thing. And you're going to have a really nice fall off on your skin weighting to pull that off. But I've done that for games before where scaling wasn't an option. So we used translate and just baked it enough that way. It's not going to be necessarily the most robust thing, but it'll get you some decent appearance of stretching, depending how far you try to take it. We'll have our own issues with this too, and you can already see some weird stuff going on with these joints. I'm going to assume that's okay. I did hook that up to scale and not shear, did I? Let's bring back up my windows. That's not the window I want. Nope, that's under scale. Output X, 1, 1. Yeah, I don't know why it's looking like that. We will just run with this. That is a weird artifact of whatever's just happened. Where did that happen? Did I hook it up to shear on one of them? Let's look at this guy. Yeah, that's probably what happened. Let's go load him back up. I probably clicked the wrong thing. Yep, shear. Let's undo that. Hook that up to scale. That's why all the other ones look weird. Okay, so I'm gonna go find. I have no idea where shear is in here. Alright, so I'm going to cheat, and because I can't find that, and I can't, my windows are minimized, it doesn't tell me which one's which. So I'm going to reload that joint again, so it's going to connect to itself. I know its rotate values are all set to 0 right now. So I'm just going to hook up something else that was already set to 0. Back to shear, and there we go. Okay, and I'll disconnect that because I don't want to keep that connected there. And everything's better again. Okay, so not only are we showing you how to do this, we're showing you how to troubleshoot when you make bad mistakes like I just did. I could have tried to undo there. If I had enough undos, that would have gone back. You know what, I'm going to go ahead and save this file right now because we're doing all right. And I am sure this will crash at some point or something because it's a demo. Let's see, I'm going to open back up my outliner. Here we go. Select my curve, and we're going to test out how that worked now. So if this worked, these should scale proportional to how long the curve is that we're deforming. So the end should roughly stay right about where it is, where the other end keeps going and everything stays uniformly spaced. So I'm going to grab a few CVs, and no, that's not working. So, all right, time to troubleshoot. Did I switch my node back over to divide? Let's double check that. Okay, so that should be 24 divided by 30. You know what? No, I did that the wrong way. I was right the first time. And again, this is me making those mistakes, but they're easy enough to undo. And the nice part is, when you're not doing this on video, it's just you that know that you made that mistake. You don't have to show anybody. You have to show all of YouTube. Okay, let's try this again. I was right the first time. Change that to 24. That's better. So I was shrinking my joints as I was doing that before. That's why that got shorter. Because 30 going into 24 will get you a smaller number. I need a bigger number. So 24 goes into 30 should get me a bigger number. And you see these are all spaced out now by 1.29. And it's roughly sticking. Although I just did something, again, stupid. I'm going to undo and keep undoing until I get back to where those are down, because I have no easy way of putting those back in position. I could try to eyeball it, but that's just a bad idea. And luckily I saved right before doing that, so even if I couldn't have undone, I could do it this way. So again, we'll just watch this again. So curve info, multiply, divide, unhooking it from input 2, hooking it back to input 1, and 24 is the original number, and it is on divide, and we'll test that again. Okay, that looks right. So what do we have so far? And this is going to be a little bit hard to see. You're just going to have to take some of my advice for this. We have right now a spline that will translate these joints. It'll rotate them, but it's not going to twist them yet because we only have a spline. It has no way of really telling if I do this, and you can see here it's, well, is it letting me, or do I have discrete rotate on? Yeah, it's not even going to let me rotate them in X like that, which also seems odd, but whatever, it doesn't matter. They wouldn't actually rotate because there's nothing there to aim these joints at to say, here's how we're rotating. They will point to their child though. So what we're going to need is something that rides along with these to handle rotation and twisting. So that's where we're going forward. And it's also why I haven't skin weighted our mesh to this yet to see how this is working. Yeah, actually, you know what? Let's do it real quick because we could see it and then I can undo it because it's not actually going to help us yet. Going to go ahead and grab that, my joint chain, skin, smooth bind. Yeah, joint hierarchy. I just change this down to 4 every time. Not that you need to, but our game engine that I'm currently working on only does 4 max influences, so it's also not a bad number to work with. And basically that means 4 joints can control 1 vertex at most before it has a cutoff. But let's see, let's go ahead and grab a few of those CVs. Did I actually get anything? I don't know that I did. I'm going to hide polygons so I can actually select them. There we go. And you can see now kind of how that's working. And towards the end gives you a better idea too, because you could see, even the tip over here is stretching. We don't have localized stretching. And we could do that with shorter splines. If we wanted to do, say, we'd still have one CV curve for the whole thing, but then we could subdivide it into smaller sections. And so make a copy and say, here's a span from here to here, here's a span from here to here, here's a span from here to here. And as those sections stretch that follow the main curve, now just space those joints locally so we get those. It's basically doing the same thing we just did, but you'd make a series of smaller curves that follow the original. Maybe the CVs are overlaying, but rather than use this curve's arc length, you'd be using those smaller sections curves arc length, and the joints that overlap with that curve would be the only ones getting the scale, rather than the whole thing uniformly. So same idea, just making it a little bit more localized. But we're not going to do that here because that will take a lot longer to set up. I'm going to go ahead and undo that skinning. Okay, that shouldn't be skinned anymore. I'm just going to double check. Yep, no skin history. Okay. I'm going to go ahead and turn that off again. So you see what it's doing, but again, so we still don't have any twists, and that's something inherent with IK splines. Now, if we wanted, there is something built into IK splines that handle twist. And let me see where it is. So we have a twist setting here, which is the overall twist. I think we have access to that, yeah, in the channel box here. And you can see it twisting the joints. So if this works for your particular need, that it's something simple enough where you only need the front twisting relative to the back end, you could use this attribute, and you could even hook the rotation up to a control in the end to that. So the rotate X of that just connects directly in the twist and handles that. So we have some other things. I'm trying to remember what roll does. Roll seems like a similar thing, but I think twist is the one I usually use. But again, it's uniform. So as it goes down the chain, let's actually go look at this. So you can see there's no rotation on there right now. Let's set this to a rotation or twist of 90. So we can look at this end joint. You can see it now has a rotation of 90 right there. Sorry, that was the twist handle. Oh, is it going to the other end? Oh, no, that's why. So it's taken that 90 and divided it by 24 because, of course, each joint is a child of the previous, so it's inheriting the rotation from the previous joint. Here there's none, and then it just, 3.9, and that compounds because that 3.9 plus this 3.9 plus that 3.9 plus that 3.9, and then eventually you get all the way up to 90 as you get towards the end. That is one option if that works for you. If you want a little bit more nuance, what we could do is we could build a series of joints that are children of this current chain. So we duplicate our chain, and then we'd make joints just for rotating an X that ride on top of these joints here. So that's what we'll do. We'll check out how that works here. And what I think I'm going to do is I'm going to build some controls first. So I'm going to go ahead and just make some really simple spline controls. I'm going to go ahead and make a circle. I'm going to go ahead and group it. And I'll give this a basic name because this will start to matter here. Nothing quite as complex as I usually would. We'll just call this CTRL1. We'll just call this GRP1. So this group, if you haven't covered this in other videos, will allow me to place this controller while keeping everything zeroed out, but be able to rotate it if like. So let's go ahead and look at this. I want to rotate this 90 degrees so it's upright. And this first one, I believe I want to place over here. And actually, you know what? No, I'm not going to rotate the group because I want to leave my transform gizmo aligned with my joints because that rotation will matter later. We want those to be one-to-one. So I'm going to rotate my control itself, freeze transformations on it. And let's go ahead and bring back up my outliner so we can see that. So, and we'll look at both. So everything on my control is zeroed out currently. It's aligned the same way the joints are. So Y is up, X is this direction, Z is off facing towards me. So same with each one of these joints. X is off down the chain, Y is up, Z facing towards me. Now, the job of this group node is it inherits the transforms of moving -12. And if it was part of a whole rig that's moving around, these would be the children of some other control, so that when I place the tentacle, they will drive the motion of that tentacle to raise up with the rest of the rig, but I could still zero out this control and it'll end up in that position relative to the rest of the rig. But we'll go ahead and make a bunch of controls like this. I'm going to go ahead and trim back on my polygon so I can see how big my NURB circle is, and I'm just going to make it bigger so it's something easy to select, easy to swipe while I'm working on my animation. I'm not going to make it too big because as I start to rotate, it'll start to clip through the other controls, but something decent size here. I'm going to go ahead and hide my polygons again so I can see, and I'm just going to glance at my curve again and see where my CVs are. I see one there, so yeah, it's just every 4. So if I know from the center 4, 1, 2, 3, 4, I know one control goes there. So I am going to build one control for each one of those CV curves that I made. So I'm going to go ahead and duplicate this, and 1, 2, 3, 4. Again, I'm holding V to snap. My joints are lined up to the grid, so that's the same thing in this case. Control D, whoops, what did I just hit? I think I hit paste. Control D to duplicate. Oh, I have something else in my scene, I think, from hitting V. There we go. Okay, so ignore what I just did there. I hit the wrong button. Control group 2, duplicate that. Hold down V and 1, 2, 3, 4. Duplicating again. 4. 1, 2, 3, 4. Duplicating 1, 2, 3, 4. And then one more duplicate. 2, 3, 4 right there in the end. Yep, so everything's evenly spaced, just the way I built my CVs. Again, remember we got that extra CV over there, but we won't worry about that for right now. And all my groups are named the right thing, but my controls are not yet. So I'm going to go ahead and rename those so I could tell what's what if I'm looking at the outliner or the node editor or the connection editor or whatever. I could just recognize them by name. And I'm going to go ahead and name each one. And it's always tedious. Naming is one of those things that takes the longest to do when building a rig, but it just makes a world of difference to be able to tell what's going on later. I'm going to turn my polygons back up, and I'm going to scale these all down so they kind of taper down in size also. Exactly doing any sort of exact science here when scaling these. I'm just eyeballing these in this case. That may be a little bit too much as far as selection handles, but again, it's a demo rig. I'm not too worried about it in this case. Okay, and I'm freezing transformations on all those to get rid of that scale value so that they don't have that. Um, Ideally, I probably should be using something that's not a circle, even a octagon or something like that, something that have edges, because at some point later on, I'm going to want to see these things rotating, and having something visual on them that tells me which way's up would be helpful. So it's not. I spend a lot of time on my control language of what's going to be easy to select, what's not going to overlap with other controllers, what's going to be easy to tell and communicate to the animator which direction this thing's facing, what it does. Is this a control you translate? Is it a control you rotate? Is it one you scale? I try to build a language, a visual language into my controls um, that may not necessarily be inherent just by looking at it, but is consistent throughout the rig. So once they get familiar with the language of my rig, they can go, "Oh yeah, that's the type he builds when he wants us to translate it. That's the type that is an IK control. This is a FK control. This is just a switch." Um, and the more the controls just communicate that to you, the better. So you know what? Actually, what we'll do is we got kind of that ridge on here. I'm going to go ahead and select all these because I'm going to have to show you guys this, and I want to show it reflecting in the control. I'm just going to grab that top CV here and translate it up. So we got this egg shape now. So at least we kind of have somewhat an idea of what's up. I'm actually going to go ahead and take those and scale them in a little bit. Make that a little bit more pointed. Okay. So we have our controls. We can tell which way is up now, so we can tell when this thing is rotating. And we want to be able to drive these CVs now. So there's a couple ways we could drive these CVs. I'm going to go hide my polygons again. I'm going to hide my joints to get them out of the way. So we could use joints just like anything else. Now the problem we'll face with these is, unlike polygons, we might want to skin weight these. Maybe I built control every other CV, and this one's just weighted 50% between this one and this controller. We could do that. We'd have to do it through, we could build a joint and through the component editor, bring this over. We could look at smooth skin, and it would tell us, what joints this thing is weighted to and what percentage, and we could say, okay, do this one 50%. Figure out which vertice that was. We could just select it, and it would tell us. You can see right here, it's not weighted to anything. But you could define which joints and change those numbers because they're limited to 100%. I don't think we're going to do that in this case. I think we're just going to make clusters, which are essentially going to be one-to-one. They're just going to be things that are objects that we can then select that drive these CVs, and we can do groups of CVs if we want. That should meet our needs for what we're doing, because we don't need to do fall off since we have controls one-to-one to each CV, or two. Everything's going to be 100% weighted is what I'm getting at. So I'm going to select those first two CVs and create deformer cluster. And we're just going to keep selecting the curve and keep doing that. So if I hit my G key, that'll do the last command that just happened, which was create cluster. And so I don't have to keep going to the menu. Again, I'll show you the menu just one more time for the heck of it. Create deformer cluster. You could also just peel off this menu if you wanted and keep clicking that button if you prefer, but G key I find pretty simple to use. So I'm just reselecting this curve, selecting the next CV, and hitting the G key. Oop, too much. Okay. Oh, you know what? That wasn't right because I need that CV also. So I undid the last one, the last cluster I made, and I'm getting the last two in there. Okay. So right now I have a cluster handle that corresponds with each one of my groups. I think if I was building a rig, usually I would parent constrain the clusters to the handles. It means I could do other things, and more importantly, it means that my animators can't ever accidentally pick walk and get to my cluster handles. But, well, no, let's just go ahead and do it. I'm telling you one thing, and then I'm going to do another because it's easier. Let's just do the real thing. So I'm going to select Control 1, and then cluster handle 2. This means this is going to be the parent, this is going to be the child of this parent constraint I'm going to make. Constrain parent, I'm just going to go into my options and make sure this thing's reset because I might have done something else earlier. And click add. And again, just like making the clusters, I could select the control, the cluster I want to parent, and then hit the G key to create that parent again. So I'm going to do that for each one of these. That's a handy little thing that makes the stuff speed up. Y key does last tool use, so like if you're clicking out joints, if you hit the Y key, it would create joints. In this case, it'll bring up the measure tool. And so if I hit Y right, and I can click out a measure tool because that's the last one I had active. So 2 very helpful hotkeys. Okay, so now if I turn back on my joints, you can see, whoops, go back to object mode. These controls are driving our curve and something much easier to place and animate with. And to an extent, they'll control, via rotation, but not a whole lot happening there with twist. Again, you could see. So we need to drive the twist of this. And so what we'll do is, let's see, I'm just doing some math in my head and realizing I'm going to have to hook up a whole bunch of stuff here in a minute, but that's fine. That's part of this. Let's go ahead and duplicate all these joints. And I'm trying to think what's a cheap and fast, easy way to do this. Okay, we're going to duplicate the joints. We've got that whole chain being named the same thing. And I'm just going to go up to modify, search and replace name. I'm going to replace joint with rot underscore joint, rot for rotation. Rename that whole chain. So you can see, if I shift click that, they're all named rot joint. I'm going to change that back to 1 so that we have a corresponding number for each joint. And I'm trying to think if I want to hook these up before I parent them. I think I'm going to do that. So inevitably, these are each getting parented under their corresponding joint under here. And this is just going to handle the rotation X for this. They're going to write under the parent, but then they'll be able to do some twisting also based off their parent control. Let's see, how do I want to do this? So we're going to have some fall off that happens here. And that is what I'm thinking about how I want to do, because it's going to be making a bunch of nodes here to kind of show you this as we go. And I'm trying to think, I'll do all of them. Okay, I'm going to hook them all up first so they twist, and then I'll parent them under their joint. And you won't get to see any of this until I'm done, so you just got to trust me it's working. But we'll start with that. So first thing, you know what, I'm going to go hide this chain so I can just click in my viewport to select these joints. So this chain is completely hidden right now. If I select any of these, you can see me selecting it, but nothing's highlighting. So we're just working with this. If I click on anything here, I know it's going to be this chain. I'm going to select this control. I'm going to bring back open my connection editor. So I have that control selected, and load up that joint. And I'm going to say rotate X. So this axis drives the rotate X of that joint. And I just want the one because, again, translating these around is going to do the other rotation. I just want the twisting, which I'm not currently getting. So that joint's taken care of. And right now we're just going to focus on the joints that are directly under a control. And again, same thing. Rotate X, rotate X. And the control and the joint. Rotate X, rotate X. X and rotate X. Pretty straightforward. So basically, if the joint is directly under control, it is just directly hooked up to that control because we want one-to-one twisting with it. Did I? Yeah, okay, I did click on that. And this is where I start to get a little bit spacey because you keep doing the same thing over and over, and you start going like, wait, did I just select the right one, or did I think I only selected the right one? Rotate X to rotate X. Okay. So those are hooked up. Now we have to do all the joints in between. And this is probably where I'm going to get very sloppy here and not name anything so that we can blow through these. So let me tell you what I'm going to do first. So this joint is 100% the rotate X of the control above it, and same with this joint over here. And so what we want to do is have a fall off. So this joint will, right in between these two, will be 50% of this rotation X, 50% of that rotation X. This joint here will be 75% of this rotation X, 25% of this one. Reverse is the same for this joint, where this joint will be 25% rotate X of this one, 75% rotate X of this one, and we'll get a nice fall off that happens there. There's a couple nodes we could use for that. We could create, there's two types of nodes I'll use for these. I'll use blend color, or I'll use a multiply divide. And either is acceptable. There's no benefit or drawback to either one. Let's see, what's going to be the easiest? So if I use a blend color node, I'll think this out loud so we could kind of see the thought process here. Let's go ahead and look at it real quick. Blend color is a shader thing, but you have RGB values. So there's no reason you couldn't plug in an XYZ value and have it work just the same. So if you look at its attribute, here's an RGB value here, RGB value here, and a blender that you're saying either be all color 1, I think, or all color 2. And then anywhere in between, it's just averaging the R, the G, and the B values. So that would do it. So we'd have one set at 25%, saying being 25% red, 75% blue, one 50-50, and then the other 75% red, the other 75% blue. So we'd have to make 3 nodes for each one, and that would work. The other option was the multiply divide node. And again, this is just showing you guys there's multiple ways to do a bunch of stuff. There's probably other nodes I could use too that would do this just fine. And multiply divide would be, yeah, the multiply divide is going to be more, because I would have to say, I would have to have them going in being divided by 25 here. So X is divided by 25. I'll have to use multiple nodes still, but I'd use a different way. So I'd have one saying, so I got 3 joints in between. I'd say, here's joint 1, here's joint 2, here's joint 3. It's all going to be rotate X for each one. So let me point to you my logic here. Of what I could do is say, this joint is this slot, this joint is that slot, that joint, whoops, is that slot, and say 25, 50, 75, and then I'd have a second one, and by each one of these being that joint, it's this control plugging in multiple times saying 25, 75, or 25, 50, 75, and then another multiply divide node for this one doing the same thing, and then it goes through an add divide. Where is it? Let's look at it real quick. A plus minus average node, and it's set to sum. And the benefit of doing it that way is I could reuse that over here. So this this could apply to both this side and this side if I was paying attention. But that actually sounds way more confusing of trying to keep track which one's which rather than just having one for each joint. So I'm just going to do that. I'm going to use the blend color node. And let's see, how do I want to do this? I'm going to try to make this as easy as possible on myself. And we'll start up front here. And I'm going to load up control 1. I'll try to get this all on one screen for you guys here. So I'm going to grab my first control. It's loaded in the from slot. Load my blend color. And I'm just going to take wholesale rotate and plug it into color 1. All I need is the rotate X, but I could do that on the out value, not necessarily in value. It'll just mean less clicks setting this up because I don't have to open that up every time. Reload this control in the from and say rotate is color 2. And this particular one I will set to 25. Oops, 0.25. And then I'll load that up as the from. Load this joint. Is that what I want? No, I want this one to be 7.5 because I think color 1 is that first controller. We'll test this out in a second and then see if I'm right or wrong. Color 1 and then the rotate joint. So output R, because RGB is equivalent to XYZ, is equivalent to rotate X. So let's rotate this. Let's just do something super simple, 1 degree. And that is rotated 0.75%. So that's right. So we're going to keep doing this down the chain and keep doing this crazy setup as we go. And this will be the point in the video you guys might just want to jump ahead. Also, I'm going to go back and freeze transformations on these controls because I think, is it just the one? Yeah, I just didn't freeze transformations on that one. There we go. And did something look like parent constraint? Yes, it did. So I'm going to, hold on. I'm going to undo that freeze transformation because I could see my cluster jump and delete that parent constraint because it was relative to how it was scaled. Freeze transformations on that control. Have the control selected again, grab that cluster and create that parent constraint again. Okay, that was a little detour, but I think we're fine again. Okay, so again, we're trying to get our twist set up. So this is where I'm going to get sloppy. I would name these each as I went to keep things moving along. I am going to just keep duplicating this and hope to God that this works correctly. Actually, let me see if I could do this. If I can do one better. Can I try to remember if there's a way to duplicate it with keeping its connections? Let's see, what is duplicate special? See, that's already hooked up, but it doesn't have any outgoing. Okay, so that's what I'm going to use. So I'm using edit duplicate special. I'm bringing open the options box here, and I'm checking on duplicate input graph. And what that means is when I duplicate this, it's duplicating the incoming connections. Because all three of these joints are going to use the same controls, they're just going to have a different blend value. So now I can just change this to 0.5. Reload from grab this middle joint, output R, rotate X. And I'm going to keep doing that. I think it was, what was the hotkey it said? Duplicate special is Control Shift D. So I can do that without the menu. I just clicked a hotkey that is going to, yeah, let's not do that. I think I just turned on the effects on my, yeah, I turned on screen draw on my capture equipment with that hotkey. So I just learned something. If you're capturing with Camtasia and you hit Control Shift D, that is how you do screen drawing. So I'm going to keep this menu open and not use the hotkey while I do this. So I'm selecting blend colors too. I'm going to hit apply to duplicate it. My window is going to get super cluttered super fast here, but as long as I can keep track of which one's which, I can keep changing this. Change this to 0.25. Oops. Not 0.25, but 0.25. And reload the from, reload the to, output R to rotate X. And oh, they all still have twist on them from that. So in this particular case, these are all going to reset them. So let's go ahead and untwist these right now. Setting that back will set back the parent joint, or the spline driven ones up here. Like I just turned that twist off. Let's see. Oh, right. Yeah, I'm not going to worry about this because it'll be fine the way it all lines up. Because the only thing we're controlling is the rotation. It's all on the same axis. If you were building something in a shape, that's something you may have to be concerned about. But that happened because I was showing something off and didn't undo it. But in our case, we don't have to worry about that. Because the joints aren't moving, they're just setting themselves back to where they actually should be by hooking things up. Okay, so blend color 3. In this case, I'm just going to duplicate it. I'm going to graph input and output connections again, just so I could clear my workspace. And because now it's hooked up to different controllers, so reload this in the 2. This controller number 2, is going to be rotate is color 1, and the next one down is color 2. And let's set this back to 75. And blend color is from joints 2. And then output R to rotate X. And really, if I was doing this on my own, I might spend time writing a Mel script for this, but particularly if this was something I had to do for 8 other tentacles or something, or 7 other tentacles or something like that. You see, every time I'm hooking something up, it's here's me creating that color node, here's me setting that attribute, here's me connecting that control to that color blend node, and I basically copy those parts out as I'm doing it. Basically, I do one, and as I'm doing it, I copy each line until I set up the one, and then I would copy that text and just edit in a text editor and then paste it all in, and it would auto-generate all that stuff, where it's probably a lot faster than hooking it up the way that I'm doing. And then, there's one tentacle set up, and then, I do a search and replace for name, switch it out to, if it's tentacle 1, search and replace for tentacle 2, and then now tentacle 2 is set up like that. So it'll seem like a little bit more work up front, but in the long run, it'll be less work. But in this case, I am just going to keep doing it via, and we just took a quick interruption break because apparently when you install enough video games, you don't get to record long movies anymore without running out of hard drive space. So I uninstalled some stuff from Steam and I'm back. Anyway, what I was saying was ideally I'd probably be scripting this stuff, but in this case I'm not going to. I'm just going to keep connecting this via the connection editor here, and we will finish hooking up all these joints here. So that one's that one. So, right, I can't use the hotkey because we just learned that. Set this one to 0.5. And again, I'm just going to keep doing this over and over. So if you want to jump ahead, go ahead. And we're just going to go through and do these each one by one. If nothing else, hopefully you're learning through repetition. All right, duplicate that. And where did that go? There we go. Number 6. Change that to 0.25. Load that up as the from. Load that up as the 2. I'm just scrolling back up to look at the name to make sure I did the right ones last time. Okay, so we have got to do that 4 more times. So just going to straight up duplicate that one. Get it down to just that, and got to hook up the controls and see, we did the first 2, so rotate to color 1 and rotate to color 2. Set this back to 0.75. Make this the from. This one the 2. I'll put R to rotate X. Duplicate special on the blend color. Change it to 0.5. I mean, if you ever want to know what the glamorous world of rigging is like, here it is. Here's half your day, and the other half is naming all these parts. Oh no, a third of this is this, a third of this is naming all these parts, and the other third is fixing the stupid mistakes that you did that you didn't realize later that you did, and correcting them. Because there's a bunch of parts like this, and it gets confusing sometimes. Which is, again, why you would always name this stuff, even though if I haven't here. What I haven't said is I really have my fingers crossed right now this goes without a hitch. And I don't screw it up along the way, so I don't have to unbury what it is I just did. And actually, I'm already starting to potentially realize the flaw in all this is that unless I parent these controls under one another, I may not be getting the type of rotation I want because I'll be able to rotate this independently from this, but these joints are, well, no, it will be fine because right now they're in a chain, but they won't be later. They'll be independent of each other. So when they twist, it won't be compounded like it is right now. So never mind. Okay, yeah, that's the hard part. My brain is real good at thinking at individual pieces when you start layering them up on top of one another and multi-levels of how motion compounds. I get confused real quick. But the fear I was about to have is not actually the case. Because, again, we're having it right under a different rig. Okay, so hooking up the next controls. Wait, no, just rotate to color 1. And again, rotate to color 2. This one's going to be 0.75. And I'll put R to rotate X. Selecting that again, duplicating special, change that to 0.5. And again, the duplicate special is just keeping the incoming connection, so I don't have to re-hook up those controllers each time that when I'm duplicating, they're already connected. And all I have to do is change the blend value and connect the output value to the correct joint. And last one on this particular chain. Or 0.25. This is probably where I should use video editing and just cut all this out, right? But we're almost there. Plus, if I do any other screw ups, maybe there's a lesson to learn there, and we'll see. But that's the great part of YouTube. If this is all boring like nothing else, just jump ahead in the video. Let's see, rotate to color 1, control, rotate to color 2. Again, just setting this to 0.75. And let's see, reload the blend color to from. That's going to hook up to this joint. X. Again, you're seeing the jump because I left the twist on before I duplicated this, so it's just resetting itself back to 0 is all it's doing, which is, in this case, is fine. Not the ideal way to be doing this, just to make sure everything's clean, but I don't think it's going to screw up anything in this case. Alright, duplicate special. Where did it go? There it is. You got buried. 0.5. And it's going to be that second joint. And by the way, I could tell that I still have my old joint loaded up because it's still italicized, meaning that something's hooked up to it. If I haven't done anything yet to it, it shouldn't be italicized. So that's how I'm partially remembering that I haven't hooked this one up yet. So reload that into the from. Switch that to 0.25. I'll put R. So again, see, that's italicized and grayed out. That means it's already hooked up to something else other than this. I could override it if I want, but I don't want to in this case. I can tell that doesn't have anything connected to it yet because it's white like that. All right, last set. Let's go ahead and duplicate him, clear out our graph. Change this to 0.75 for the first one. Load that up in the 2, and then we'll connect our controllers to it. Where is it? There it was. Rotate to color 1. And reload the from. Rotate to color 2. All right, we should be able to hook this up now. Reload the from as the blend color. The 2 is that joint. Output R to rotate X. And going to select our blend color, duplicate special. Change that to 0.5. I'm just going to keep trying to talk through this so that if you're still following along, you hopefully get the pattern here at this point. And last one. Whoops. 0.25. Yeah, and keep an eye on that when you hit enter. If you did a typo or like did double period or something like that, that may not actually change. So just keep an eye on it. Make sure it's changing to the number that you want. And then output R. Rotate X. Okay, so thank goodness, I think that's the last one. Okay, so there's all our twisting nodes. I'm going to go ahead and close that. So now we can parent these to their existing nodes and just have that hooked up because these should each be hooked up to something now. I'm just clicking each of these, looking at that channel, just seeing that they're all staying yellow, which they are. So we want to drag these up. Holy cow, did I? Oh no. Okay, I just realized what just happened. So I said duplicate input graph. I forgot that it does this, and I was trying to cut corners, and that doesn't work that easily. This is where I should have just scripted this. So every time I did duplicate input, it made a new input control to go along with it. So now I've got, I get to go make, or not make, I get to go delete these extra controllers and then hook them up, hook the blend colors up to the right one. So first off, if you didn't know this, you could grab your outliner at the very bottom here. You see that little dotted line? You highlight it, you could split it into two. I'm going to scroll down here. First off, I'm going to delete all the extra controllers I made. Yeah, I tried to do it, like make this faster through Maya, and the way you do that is through scripting, not on here. I need to do some scripting videos for you guys. Okay, so I split that apart, and the reason I'm splitting this apart is one, so I've only got those controls. Two, I'm going to unhide DAG objects and find all my blend color nodes, and I'm just going to work backwards through them. And up here, I could find them here. And just FYI, by the way, the thing about splitting, you could select anything on either part. It's, same view, but you can only rename in the upper one. So if you're trying to double click in here, like I want to rename this, nothing's going to happen. But if you do it up here, you could totally rename up there. So, okay, let's just open up our connection editor again, and 2 steps forward, 1 step back. Not a big deal. Okay. So rotate, okay, that's right. And this first one should be right, I'm guessing, because that's what I duplicated off of. So here's number 2. Yeah, so how do I want to do this? Okay, yeah. So the first 3 are going to be this one. So the first 3 blend nodes are going to be control 1, control 2. I know that much. And then let's do number 3. And control 1 is color 1, control 2 is color 2. I should have just done this from the start, but whatever. All right, so that's 1, 2, 3. So now I need 4, 5, 6. I know it's going to be this control and this control. At least these are all staying relative to the screen. Okay, yeah, so the first one is going to be set up right because that one I actually had to go hook up the controllers. It's going to be the ones in between. So I'm going to skip 4. I know 5 is going to need to be hooked up right. And then 6. I'm just going to leave that one loaded because I know it's color 2. If you don't fully understand this, don't worry. Just the thing I learned was I need to just hook these up. That duplicating input connections was duplicating that whole hierarchy of everything that was connected. So not just duplicating the connections, but duplicating the thing that it was connected to along with it, which isn't exactly what I wanted. Okay, so 7 should be good because again, I hooked that up manually. And then 8 and 9 need to be hooked up properly. So rotate control 1, rotate to color 2, and then let's do number 9, because I just did controller 2, 1. So basically I'm selecting this one, hooking it up on the middle one, select this one, hooking up on the middle one, then I grab the next blend color, and then I know because I just had controller 2 loaded up that that's color 2 for this guy, and then I can go back and load controller 1. So it's saving me a click by doing that. Okay, so 10 should be set up all right because that should be that guy. And that. Color 1. Color 2. That is number 11. Number 12. I know I'm on. Well, that's hooked up right. Oh, because I didn't actually reload it. There we go. And I am doing Control 5. Losing track of where I am, guys. I think I'm still doing this one, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm on number 12. Yeah. It's the last one. Okay. And then 13 should be good. And we need to do 14. And I don't know if you could hear it, but my dogs are probably barking at a coyote out in the yard. Hopefully it didn't come back. Completely unrelated to this, but nonetheless makes it all the much harder to talk to you guys while trying to record a video. Let's see, so that's that one, right? Okay, yeah, and that's that one. So we're on 14, that means we're doing 15. This is where naming this would have made this a whole lot easier, and I could figure out which joint it corresponds to. This is the part I have my fingers crossed on that I am kicking myself because I knew it would come up. But we'll get through this. So rotate color 1. This controller's color 2. And then, so that's number 15. I know 16 should be good. And it's just 17 and 18, which are the last two, so we'll load those up. That control is color 1. Wait, no. That control is color 1. And that control is number 2. And last one. Okay, I believe those should all be hooked up properly now. I mean, I could, kind of eyeball it a little bit there, but it's still kind of hard to tell. It'll be easier to tell once we're hooked up, and if there's specific problems, I can go back and tweak that from here. Okay, so I'm going to turn off, or turn on show DAG objects only. Go back to here. Actually, I'm going to go back to split screen. I'm going to have my rotate joints down here at the bottom and find my translate joints up here at the top. And here, at least the name kind of helps because the numbers are the same. So I am just going to select, I don't need this end effector because that was just duplicated over from this one up here. There's nothing controlling these joints other than the controls we just hooked up. There's no IK handle controlling these. So I'm going to delete that, and I'm going to select rot joint 25 and the control click joint 25 and hit P for parent to parent it under there. And then I'm just going to keep parenting the previous joint, or the rot joint under the corresponding joint. And I've already screwed it up. Okay. I'm going to try not to talk. Okay, 24 to 24, hit P. You have caps lock on, that won't work. Just keep an eye on your keyboard if you're trying to follow along. 23 to 23, P. I could also select this and middle mouse drag up to that joint, but you can see it kind of scrolls up along with it, which is kind of annoying, so that's why I'm doing the control click method. 21 to 21, 20 to 20, 19 to 19, scroll up there a little bit, 18 to 18, 17 to 17, 16 to 16, and just so on. And this isn't even the worst of it. I've done tentacles that are, I don't know, like a 30, 40, maybe even 50 joints long, and it's the same process. It's just, they're always a little tedious. But again, this is where I would be, so each time I'd parent this, I'd be copying out the mel script for this. I could edit this down to just say select R rot joint 9 and space joint 9, and that'll be all one line. I would select in that order and then say parent after it, and just keep doing that so I could do a search and replace for when I do the next tentacle. And that way I just have a script that hooks all this stuff up together. And all I have to do is build out the base skeleton oriented the way that I want, and then it does a lot of this stuff on its own. Particularly if you could rebuild the curve like we did, if just you click out a single point saying, hey, build it on, figure out what point the first joint's at, figure out what point the second joint's at, parrot it into that and just go. And last joint. Okay. So now we've got our twisting set up with our IK spline. Now we need to skin weight this thing. And the rotation joints are going to be what skin weights this thing. It would have been also easier if I had done this first and then parented them, but not always the option when you're doing a real rig, because a tentacle may be attached to a monster or whatever else, a squid or whatever, that also needs to be skinned to certain joints. So in this case, rot joints are my skin joints. I'd name those something else if I was doing a real rig, but I'm not. This is just for demo in this case. I'm going to grab, let's go ahead and trim back on my polygons. And, whoops, control select my cone. So I've got just the rot joints that I made and my skin. I'm going to go to smooth bind, bring open the options, and rather than joint hierarchy, I'm going to tell it to skin to only the selected joints I have. And this should be it now, I think. Let's see how we did. I'm going to go ahead and turn on wireframe on shaded here so you guys can see a little bit better how this thing is deforming. So that's good. Yeah, that's looking like what we want. If I stretch it out, it kind of does along that path. That's looking cool. I don't have to worry too much about skin weighting because it's pretty uniform along everything. So that all just kind of worked out for us in our favor. So the twisting part, let's see how we're doing on twisting. So yes and no. And I'll show you what's going on. So you can see it's twisting down here. Where did my mouse go? My mouse is freaking out. Okay. Hopefully this isn't Maya about to crash. So that'd be real bad because I forgot to save. Okay, just saved. And I think I'm going to take a break because I can't move my mouse right now. Oh, you know what? I know what happened. I'm on a USB mouse and I haven't hooked it up to a charger and I don't know how long. Not USB, a wireless mouse. Oh, hey, my mouse works again. Ha! Again, live demo. So here's the drawback with this is because, let's go ahead and turn on X-ray joints. Hopefully you guys can see that. Well, it's twisting down over here, and that's because we've scaled out our joints. And so these controls don't stay relative to the joints necessarily. So if I go ahead and zero these all back out, and again, this is why we have those groups over our controls. So nothing isn't working here as expected, just unaccounted for. So if I don't scale this, then it's fine because that joint is still relative to that. As I stretch this out, because I don't have stretching. Okay, I'm gonna pause this real quick and make sure something's not eating my pets. 1 second. Okay, I'm back. Everything's fine. It's just I'm recording a video, so of course a bunch of stuff's going on. So again, nothing unexpected here. It's just how it works. So if we had done local stretching per each segment, where if I was to pull this out, it would only stretch between the joints from here to here, then we'd be doing much better as far as being able to have predictable twisting. But because they're scaling uniformly, all these joints back here are scaling and pushing it out up to here. So now the joint that was over here is over here now. So as I twist, you're seeing that go on. Let's see. Let me think. How hard is it to show this to you guys? Let's go for it. Let's go ahead and do different scaling. So let's see. What am I gonna do? Let's first make sure everything's reset here. Yep, it's not. Let's go ahead and zero everything out that I have potentially touched. Okay. So for the most part, working as expected, but not necessarily predictable to the animator, which is what we want. So if we could keep things scaling relative to the space between these controllers, this might work out better. Now that there might still be flaws with that of, I can move these individual sections, but as I do that, like this would then be stretching in between here. So, it then becomes relative to the overall position of this, and I don't think we'll get that same nice kind of sliding that we do like that right now. So things to be aware of, of trade-offs, and we can see the difference. So like right now, if I pull this tip out, and so that joint is right here, watch it, keep your eye on this joint as I pull that tip out right now. I mean, I could pull it all the way down to the next controller, so now, if you're visually looking at it, you expect it to twist down here, but it's actually going to be twisting down there. And maybe for your workflow, that's still the best option because you want that sliding effect that it could, go over objects. But let's see how it works with local scaling. And what we'll do is we'll create little sections that give us individual scaling like that. So let's see, how is the best way to do this? Because that's not going to deform the same way anymore, is it? So let me turn off my polygons and show you guys that dilemma. So if I translate this up, I've only got 2 CVs here. I've got one, we made one cluster per CV, but it's averaging between 4 points. It's taking that point into account and averaging that curve. So how do I get that overall length? I could do that with something that's longer, but I won't get that same type of motion. That it becomes linear now instead, which is not great. So I could get an approximated scaling between point A, point B. That might work, but that still looks like a longer distance from that point to that point. No, that might not be a great answer either, because again, then I can't do stuff like that. Now what I could do is cut this in half. That might be the answer. Because it'll be a little bit more predictable at least, because we need 4 points to do this. I could say cut this right here and have 4 points and then have 4 points at the length of this curve. So if I'm at least translating over here, it's not going to be moving the back half or the front half of my tentacle and vice versa as far as that. So let's try that and see how that works. Now, the better option might be to actually rebuild this curve with, say, as many points as there are joints. And then maybe rather than clusters, use joints and then skin weight them so there's fall off between those curves. That might be better. And I might have to use rotation to handle that curve better, because right now, because there's only one CV. So so that is one option, but I don't know that it's going to solve our overall problem as the tentacle stretches. We lose relative position. So let's try this first. And by the way, because that's an IK handle, we could always go and recreate that here in a second if we need to. Let's start with that first. So I'm going to go ahead and kind of do this the way that we did originally. Actually, I'm gonna go ahead and hide everything so I get it out of my way. I'm gonna create a linear curve, and I'm only gonna do half and half this time. I'm hitting Y on my keyboard so I could use the tool again. I'm holding X to snap to the grid. Okay, so I got two curves, and I'm going to rebuild them. So I'm going to go back to my surface set, edit curves, rebuild curve. Okay, so that last one that I did was 6, so let's guess 3. Let's see if that was right. Yep, 3 was right. So it's still divided the same, then we have that extra point on the end. Let's go ahead and do the same over here. Let's go ahead and turn on the construction history for these again. So arc len -ch for construction history. Turn it on to 1 because that's a Boolean, so 0 is off, 1 is on. It's a true false statement, basically. Do the same for this one. All right, and you can see that that one's curve info 3, this one was curve info 2, so you can see how those get named as we keep going. And let's see, so I could select both curves, like so these two curves plus the original one, select the CVs and do clusters. I'm not going to do that because we already did them and I'm just going to avoid steps. But it'd be the cleaner way to do this so that I know they're all moving together. But go back to animation set, create deformers, cluster. And I'm just going to go ahead and go down the line and make a new set of clusters. Now when I get to the middle here, I'm going to grab both curves at once. And because those are always just going to move together, they'll still be separate curves with separate curve info nodes, but the points will move as one. I'll show you that here in a second. So if I grab that center CV, it's moving both lines as one. So they kind of move as one. You can see them coming to a point there, though, that shows that they're disconnected. And so what are we going to do? We're going to take that curve info. We need a second multiply and divide. And let me open up my node editor again. Figure out if any of these windows I already have open are that. I'm going to leave this open because I'm going to need that in a second. I have 2 of those open. Okay, so window, node editor. And I'm going to unhide everything, turn back on my joints, and map them in my node editor. Okay, so here's my multiply divide node that the original curve info 1 is going into. I'm going to take, let's see, I'm going to take this one, duplicate it first. So I'll have 2. And I need to get my outliner back up. And let's just turn off DAG objects. So you see how fast this is filling up now, and this is just the one rig. But also I apparently pasted in a bunch of stuff from another rig. So that's extra stuff, ignore that. Anything that says pasted on the front. Anyway, what I'm looking for, but by the way, if you ever do this, just you'll either have to delete everything out or hopefully you saved recently, you just go back and undo this, but there's no undoing paste, unfortunately. So mistake on my part. I am looking for these curve info nodes though. So here's 1, here's 2. I'm going to select those and then I'm going to shift select. Well, I'm just going to grab them both here because I can see them both here. Using control and graph them both. And good God, where am I? Okay. Just going to move those all out. Okay, I can see these all now. Get them in one spot. Okay. Curve info 2, curve info 3. So multiply divide is 1 is going to be the first half. Multiply divide 2 is going to be the second half. Because I duplicated multiply divide 1, we know the length these are. It's now going to be 12 though, because it's half the length, and I just know that because that's half the grid length. and I'm going to open the connection editor. All right, multiply divide is going to be the 2. Curve info node 1 or 2 is going to be the new input X. And you can see everything, it was stretched out too far before. Let's go ahead and when I connect it, it goes back to the right length because now it's doing the right math. That's 12 divided by 12 is 1. And we're going to do the same thing over here for the second half of the tentacle. And now I need to go ahead and actually I'm going to bring that back up, but not full screen. Take that second multiply divide, bring that as the from, and then hook it up to the scale of all of these joints. So output X is equal to scale X. Oh, wait, something's, oh, is this still 24? Yeah, it's still 24. Here's that back to 12. Okay. And again, I'm just going to reload each one of these and hopefully only hook it up to scale and not shear this time. And this, again, might be easier had I made a Mel script before that did this. I could just chop off that second half and do a search and replace for connections, but this will work. It just takes a little bit longer. Also, if you use Mel scripts, use something like Sublime. I think it's Sublime Text or Notepad++. Don't bother with Notepad, or if you are going to at least use WordPack that has formatting, but yeah, just be aware of what you're using. And I don't think I need to do this end joint, but I'm going to anyway. Okay, so let's see how this handles differently now. Let's go ahead and get these out of our way. So I'm going to grab the end here. Oh, you know what would help if I hooked up those new clusters I made to follow the controls, which they don't currently. All right, let's go down the line and do the same thing that we did before. Control, grab a cluster, and then parent constraint. And I'm just going down the row to do each one of these. Okay, so if I move the end here, there we go. So you can see it's only scaling from this half now, and it's leaving this half behind. Let's go ahead and turn back on our polygon model. So we're getting a little bit more localized scale, which is a little bit more predictable. We're still going to have the same issue with the joints being off from the twist, but at least now it's closer than it was previously. And even if we're not as happy with that, we can start to adjust that. Now, one other thing that you might have noticed is that rotating these in the other direction really has no effect, and that's because there's only one CV there. There's nothing twisting this curve. Now, if we want some effect over that, we can make more CV points for our curve that's driving our spline IK. So let's go ahead and do that. I'll do one last thing here and we can see this. And you can see how we're iterating upon this. We're trying stuff, seeing how it works for our particular case, and then iterating. And it's like, well, this part works, but this part isn't quite doing quite what I want. What can I do to make that better? So we split where this thing is scaling from. That helps a little bit. So as this gets longer, it's only getting longer on this side, not so much on this side. But yeah, let's get another level of rotation in there. So I'm going to open up the outliner. Actually, I'm just going to hide everything to start with. Let's see. What am I doing? Alt H will just hide everything. I don't know what I'm doing. All right, so I'm going to make another curve, and again, so I get the nice little spacing on the end that seems to have with kind of the doubled up vertices or CVs on the end. See, we're doing 6 before. I'm going to switch over to surfaces and a curve. And again, I could just click this out if I wanted to. It's just me being a little bit anal about this and how I do it. So we did 6 previous for the long one. We could do 12 to double it, or let's do straight up 24. And that should be, yeah, 1 per a spot. So in this case, rather than clusters, I'm going to use joints to drive this. Actually, first let's go ahead and make our arc length. So we have scale for this. Wait, do I need that? No, I don't need that. I could add that later if I do, but I don't need that. This is just for our IK. So I'm going to make a new set of joints. Skeleton tool, joint tool. And I'm just going to hold X. Oh, I'm apparently turning off SnapToGrid. I already got SnapToGrid on. I'm going to turn that off. Hold down X to temporarily turn it on and just snap it to the end. And I'm not going to click out a chain. I'm just going to duplicate this. So same spacing we had before. Actually, I'm going to go ahead and delete that one. And turn that to, I'll make it a little bit bigger this time, so they overlap our actual skinning joints. So duplicate that and snap to grid. 1, 2, 3, 4. So it's spaced out the same amount as our controllers. Duplicate. And 2, 3, 4. I was holding V instead of X, which is snapped a point, which doesn't help us. 4. Duplicate. 1, 2, 3, 4. Control D. 1. Oh, hold down X. 1, 2, 3, 4. And okay. So I have our controls spaced out just like our joints spaced out just like our controls. Again, I'm not going to name these. I really should. Hopefully, again, that doesn't come back and bite me. But go ahead and unhide everything, Control Shift H. And I've got my new curve. So I'm going to, oh, here. I'm doing stuff in another window you can't see. So I'm going to select all my joints and select my curve. And I'm just going to, again, smooth bind to selected joints. And I believe that should have roughly even skin weighting across those. So I don't think I should have to do anything. I'm going to go ahead and again, select my control, select that joint, constrain parent. And if you're doing a game, these joints don't need to go into the game. They are just driving the rig. The only joints in this case that would need to go into the game engine would be the rot joints. You'd name those whatever your game engine is looking for joints. If they need to be separated, you could, make your rot joints and then make your actual skinning chain and parent constrain them to follow this one. You can have an FK rig also in here and then parent constrain on them both and then make a blender that swaps back and forth between what they're weighted between. There's a lot of options. Okay, so we've got that set up, and actually I need that back open. No, not you. And just go to outliner. Okay, so that's falling, but it's not actually hooked up yet. So I'm going to see, how am I going to do this? So I'm going to delete my IK handle. I'm going to shift click all my joints here. I'm going to hide all my rotation joints so I don't accidentally select them while doing this, because I've got to click on the ends again. And I'm going to select that joint chain and this curve this time with our extra CVs in it, and hit Alt-H to show only those two, and I'm going to again make an IK Spline handle tool, and it should have our same settings as before. Yep. And click on the beginning, click on the end, and then click on our spline. And that should have all worked. I'm going to hit Control-Shift-H to re-show everything. And now I believe my skin weighting is decent. I get a little bit of effect out of rotating those because there's fall off on that curve, and actually you can see the difference between the curves, which one's which here. That's our old curve probably. And no, these are our short, that's our shorter curve. Yeah, I think this is actually falling off differently because of that. But yeah, you can see as I get up here, it kind of kinks in. So it's just different. I can get a little bit of control out of that and how that affects, and again, how it slides. But that just might be more intuitive for either your animation or your animators of having that. You can see actually doing that, it starts to pinch a little bit more than just leaving it straight, because it's, well, I mean, it's not rotating the joints necessarily more. It's giving you a greater curve. Let's go ahead and hide our polygons, and let's. Nope, I keep grabbing the wrong windows. Outliner, and select that new curve that we made. So that's our new curve. So that's our old curve. So you can see a real difference in how that's translating with the bend in it. With the rotation, you're getting a much sharper arc than that average that you had before. So maybe this one's better for what you're doing for the type animation. Maybe this one's better. It totally depends on your particular situation for which you prefer and which is going to meet your needs better for what you're animating. But we've covered a few ways to do this. There's more things you do. I mean, like, we don't have to drive this curve with these controls if we want to. So we could make a whole nother chain like this. You know, I was talking about making an FK version of this and the IK version of this, which we just made, you know, and making a skidding joint chain that then you parent constrain to both. And let me show you underneath here in the outliner first that. So whenever you parent constrain something, each item is going to be listed here. So like if there's two things, it would be control, you know, 1 W0, and then control 2 would be W1. And you could hunt, you know, again, it's binary. So 0 is not following that at all. 1 is 100% following it. So you could set up a set driven key hooked up to control that says I want FK. When it's FK, this is set to, you know, 0 and 1. And when it's set to IK, it goes from 1 to 0, switching between those. And you could have 3 rigs if you wanted, and, you know, only one of those on at a time. And as you switch in between, you know, it's following only one of these rigs. Again, you'd have one chain of joints that is just, here's the thing that's going into the game. This is the only thing stuff is skin weighted to. No driving rigs under it. You'd have your IK rig, which is all separate, which is what we've built here. You'd have your FK rig separate, and it's all right on top of each other. It's just, you know, rig on top of a rig on top of a rig. You know, which is just controls driving joints, just almost like you're rotating, but just so they don't have to rotate the joints directly. And we could do a third one. So rather than, say, IK driving this, or clusters, well, it's still IK, but rather than the clusters driving it, let's go ahead and, for show, let's delete these. And instead of having my controls drive this rig, I could use deformers. So I'm going to make a nonlinear deformer here and add a sine wave to this. Let's go ahead and rotate that so it's facing the right way. And open up the attributes, and let's turn up the amplitude. And you can immediately see what it's doing there. It's deforming this. Let's see, I could turn the wavelength up so it's a little more wavy. So, by the way, notice it's not scaling. It's because I didn't apply the sine wave to the other two splines that are actually controlling the scale of it. Actually, let's go back and do that too. So I'm undoing that. I'm going to open back up my outliner. Let's just delete all our clusters and grab all three curves at once and apply the same nonlinear deformer to them. So again, let's turn this 90 degrees. And we'll turn up the amplitude. Actually, this doesn't look like it's scaling for some reason. But anyway, you get the idea. Again, here's something to troubleshoot. I'm not going to keep going all the way through this, but you get the idea here. So you could have drop off on one side, so it starts to taper. So 1 versus -1. You change the high bound and low bound as far as how far that goes. And so the fun stuff is, like, I've done sperm tails before using this, where actually let's go ahead and turn those all off again. That was on 2. Okay. And let's go ahead and grab those curves again and create another sine wave. And we'll go ahead and rotate this -90 just like we did before, but this time we'll also rotate it -90, or I guess 90, either way, sideways. And let's open back up our outliner so we can see this thing. So actually here's both inputs, and we can turn the amplitude up to, let's turn the low bound back up. Oh, -1, that's why that wasn't working. Come on, type. Did I turn off numbers lock? There we go. Okay. So we have that one going that direction. Let's turn down. Let's get it so we can see all this. Let's turn down the amplitude. And then do the same on sine 2. If I'm on here, I can see both. So now you can see they're going both ways. So if we were to keyframe this and keyframe the offset, let's try this and see what happens. And set the offset to, let's say, 4. And then do the same on this one. Oh, I think that was that one. Yeah, so keyframe that one and offset of 4 at the end of the timeline. So you start to get some cool motions that would be really hard to animate otherwise using these sine waves. And actually, if I believe if I offset of 0.5 more, so 0.5, so they're not hitting the same peak, 4.5. Yeah, now I got the swirl going on, so let's look at this. So I think our problem is one amplitude is higher than the other. So I'm going to say change that to 0.2 and this one to 0.2. They're even. But now we get that corkscrew action. Well, at the end, because I have them keyframed at both sides. So 0.2. too. So I'm offsetting them by 0.5 units from each other, so a half unit, so that their peaks are opposite or offset from each other at least. So now we get that cool swirl action. That if we're going that way, yeah, I guess if I had it offset negative, it would be that kind of corkscrew action, like a swipping action. But so there's a lot of things you can start to do programmatically via there. You could hook up an expression that would start to drive this stuff. I've done that before with just straight up FK controls and then saying, hey, your rotation is this plus this amount of offset time, and just drive the direct rotation of that stuff. But there's a lot of different things you can start to do with this, and it's just basically making a rig for each type of motion you want, and then you can blend between them. And again, if you need to see this, look up some of my videos on FK, IK switching. Character arm stuff is basically the same thing you're looking for. But hopefully that informs you on how to make a tentacle. Just again, for clarity, these don't do anything. Oh, I totally lied. These are still, what are these controlling? Oh, right, the joints that I made. That's what's controlling the scaling now, and of those other ones, because I skin weighted before, I forgot about that. Those things are being double transformed, which is why the scale. So they're skin weighted and deformed, which means they're not getting the full transformation of any one. So actually, if I delete these, will that show that? This is all just confusing because I did too many things at once. Oh, whatever. I think we lost some of our scale, but our stretch, but still getting that same cool motion. Anyway, hopefully you guys are learning what you need to learn to be able to do the tentacle rig that you need to do. Again, mix and match the stuff as you go. It's just building blocks that help you get there. We built just a regular FK chain. You could animate that FK if you wanted to start with, and just build these controls and just rotate and have them directly rotate these things, rotate the joints. We then added an IK, a spline IK to those joints on a curve that we made. We then made clusters to drive that spline. We tried a few different ways of scaling that spline to drive the scale of the joints. Then we backtracked and said, no, let's not have these controls deform that spline. Let's have a nonlinear deformer like a sine wave control that. And now I get to do this really cool animation that would be hard to do, that you could even then blend into the animation of that. Actually, let's test that theory. Let's go back before I deleted stuff. With these skin weighted and that sine deformer on there, I'd have to do some, again, troubleshooting, figure out what's going on with my scale, why it's not falling. There's clearly something not hooked up, but hey, I could do both now with those still skin weighted and that nonlinear deformer. It's a little bit chunky in spots, it looks like. Also, I've got, this might be a better case for having that first line I did with the less points, but here it is positioned and it's still spinning. A little bit more complicated to work with, to figure out, to try to keep track of what's going on, because you have motion on top of motion. But there's a lot of cool stuff you can do when you start layering this stuff. So anyway, hopefully that shows off how to skin a tentacle, and good luck on whatever rig you're making.